Concept 3, finding sequences of transformations. So when you're trying to determine which transformations took place in a sequence, so you have the first figure and you have the last figure, and you've got to figure out what goes in between or what happened to that first figure to make it end up where that third figure is. You're going to use what you know about our four transformations, okay, because they do different things. All right. Remember, if you have two figures that are different sizes, there had to be at least one dilation in there, right? Because dilation changes the size and the location, although not the quadrant. Okay, it'll never change the quadrant that a point is in, and it won't change the orientation. Okay, it's a good thing to remember that the change in location from a dilation doesn't change the quadrant. Okay, a translation will change the location to wherever the translation moves it, but it'll never change the orientation or the size. Okay, so if you have a sequence of transformations and the orientation doesn't change, well, you know you've got to have a dilation and a translation. Okay. If you are looking at a rotation, it'll change the location and it'll change the orientation, but it won't change the size. And it changes the location in a specific way, right? A rotation and a reflection will not change the value, so the numbers in your coordinates. It'll change them from like x to y, so it'll swap the values, and it'll change from positive to negative. Okay, so if you have two figures and their coordinates have the same values in them, well, you know you probably have a rotation and a reflection, but not a translation or a dilation. Because these ones, their change in location will change the values that you have in the coordinates. These ones will not change the values. Okay. Rotation changes the orientation as well, but not the size. And then a reflection changes the orientation, although in a different way than a rotation. And again, not the size. So let's look at our first one. We're going to go through two examples. So when I'm looking at this, the first thing I notice is that they are the same orientation. Okay, and it's really easy to see that when it's not a regular figure. It's not a square or an equilateral triangle or something like that. I notice that my figures have the same orientation, which automatically means they didn't go through a rotation or a reflection. Okay. The second thing I notice is, it changed size. And I can figure out what my scale factor is right now. My original one was 4 on its top length, and this one is 2 on its top length. So it had to be a scale factor of 1/2. So I have a dilation in here. Okay? A dilation with a scale factor equal to 1/2. All right, I know that's somewhere in my sequence of transformations. Could be my first one, could be my second one, but I know it happened. All right, and because of the orientation changing or not changing, I can rule out these two. So I'm really looking for this dilation and then a translation. Okay, and what helps me is once I've figured out, I had to go through a dilation, start with that one. Okay, let's do that one first. So I'm going to get my coordinates. Okay, so my A coordinate is 1, 2, 3, 4, 5, 6, 7, 8. So -8. And 1, 2, 3, 4, 5, 6, 7, 8. So it is at -8, 8. And B is, because they're on the same height, also got to be 8, but it is only going to be at -1, 2, 3, 4. So -4. C, It's on the same x value as b, so it's got to be a -4. And it's going to be 1, 2, 3, +4. Okay? And my last one, D, this one was at -4, so -6. And it's the same height, so -6, 4. Okay, so there's my coordinates. I know it's going through a scale factor of 1/2, so I could say that A prime is going to be half of that, or -4, 4. B prime is at -2, 4. C prime is at -2, -2, 2. And D prime is at -3, 2. Okay? And there I've got my figure. I could graph it and then use that image to help me figure out what translation I had to do to go through to get this one. Or I could do it mathematically. And I think I'm going to just do it mathematically. So this A is at 2, or this A double prime is at 2, -2. So A double prime is at 2, -2. Okay, and what I'm going to do is actually move all of these down here. And my B, I won't go through all of these, but my B is at 4, -2. My B double prime, 4, -2. And that should be enough for me to be sure of my movements, okay? To be sure how much and in which direction I translated. So I'm going to have -4, and that -4 became 2. So -4 plus what equals 2? Well, -4 plus 6 is going to equal 2, right? I got to get 4 to get back to 0, and then another 2 to get to 2. So I did a plus 6 for my x value, so moved it to the right 6. And let's make sure that that's the same for B. -2 plus 6 equals 4. Okay? So, looks like I had a plus 6 or a 6 to the right. Okay? So, 6 to the right. Now, I went from +4, so up here, +4, down to -2. So that would be a downward movement, or a negative, and again, this looks like it's 6. And they both work out with 6, so, and 6, down. Okay? So, if I was going to write out my sequence of transformations, I would have a dilation. So over here, dilation by a scale factor of 2, and then a transformation, um, 6 to the right, and 6 down. Okay, and notice I have a -6 here. But when I'm writing it out, I don't write -6 down. The fact that it's in the downward direction tells me that it was -6 for my y coordinates. All right. Okay, we're going to try and do another one quickly for some of our other transformations. All right, so here we've got 2. First thing I notice is about these ones is the orientation is different. Okay, and if I scroll back up, a change in orientation means that it's got to be either a rotation or a reflection. Okay, and then I notice that I don't have a change in size, so I know I don't have a dilation. Okay, and then the last thing I'm going to look at is what exactly happened for my orientation. Okay? If it's a reflection, my A is either going to end up directly below my D, all right, down here, or my A and my B are still going to end up on the same horizontal plane. All right? Basically, in a reflection over the x-axis, your A and your B are going to come down here, D and C are going to stay up here. Or a reflection over the y-axis, A and D are going to stay close to my y-axis, B and C are going to stay far away from my y-axis. Now, it doesn't look like that happened. It looks like I actually do have a rotation, and if I turn this, I can see, yeah, actually my A prime and my A line up, my B prime and my B, C and C prime, D and D prime. So it looks like I had a rotation of 90 degrees clockwise. Okay? And that's really the only thing that's going to get my vertices to line up in the way that they do. So I know I've got a rotation 90-degree clockwise. And then to get it back up here, because a rotation won't move it back upwards, I'm going to have a translation. Right? So I know I'm going to have a rotation 90 degrees clockwise, and I know I'm going to have a translation. Okay? So now I just got to figure out how much my translation is. And to do that, I'm going to do my rotation first. Okay? So if I am rotating, my A is at 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. My A value is at 4, 6. Okay? I'm going to, because I'm rotating clockwise, and if it's something that you forget, whether you're changing the sign on your Y value or changing the sign on your X value and then switching, just figure out which quadrant it's going to be in to figure out which value should be negative. Okay? If I'm here, my X value is going to still be positive. My Y value is going to be negative. All right? So in that case, I'm going to want to swap my values and make my Y value negative. Okay? So A to A prime should be at 6, negative 4. Okay, and I can do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this should be my A prime. All right, and I can kind of just use the shape and say, okay, if this is down 1, 2, 3, 4, then it should be left 1, 2, 3, 4 because it rotated. All right, so this should be my A prime, and this should be my D prime. Okay, and if B is 3 to the right of A, then B should be 3 below, or B prime should be 3 below A prime. All right, and I could do this mathematically, but I'm pretty confident in where I put these. So let's just go ahead and count to figure out where or what my translation was. Okay, so I went, here's my D, or my D, oops, this should be double prime. D double prime, A double prime, B and C double prime. My D came over right there, so that was 1, 2, 3, 4 to the left. So 4 left, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 10 up. Okay, and it is important to remember when you're doing this counting that you're not just going to any point on that rectangle. You have to be going from the same point. Okay, I started at D prime, I have to get to D double prime.